So again, just with like our formulas the other day, you're going to have to mostly memorize these formulas so that you can recognize them. So here we have cos squared pi over 4 minus sine squared pi over 4. Well, pi over 4 is on your pi plate. So if you wanted to do this one directly, you could. You could have root 2 over 2, and that'll be squared, minus root 2 over 2, and that would be squared. Mental math, this isn't too bad. Can you see that those things are the same? You're going to get 0. So that's one way that you could do part A. The other thing you could do for part A is you could recognize, hey, this is cos squared theta minus sine squared theta. That's one of my formulas. And I could write it as cos of 2 times theta, which would be cos of 2 times pi over 4. And 2 times pi over 4 is pi over 2. And our x-coordinate at pi over 2 is 0. So you could get it that way as well. This one, I think it doesn't matter which one you choose. Okay? Can I erase this? We're going to look at B. I'm going to look at B and both the ways you could do B. So either you could say, I know that tan of pi over 6 is root 3 over 3. So you could plug in everything into the formula. And now you'd have to simplify this till you got to a single fraction to get the answer. So if you plugged in everything right away, there's just simplification that needs to be done. You'd have to get a single fraction on the bottom, single fraction on the top, multiply by the reciprocal, and get your answer. If we wanted to use the formula, well, our tan 2 theta formula is 2 tan theta over 1 minus tan squared theta. And if we look at the equation we have right now, it doesn't quite match. The top is good, right? But the bottom is off. How would you get the bottom to look the same? Right? Can you see that if you factored out a negative out of the bottom, the 1 would become positive? And the tan squared would become negative? But it still doesn't quite match the formula, right? Because now there's a negative on the bottom side of your fraction. Some things about fractions. Did you know that 1 over negative 2 is the same as negative 1 over 2? Is the same as just negative 1 over 2? Agreed? Do you know that about fractions and negatives? So I can take this negative that's right here and just put it in front of that whole fraction. And then what's in the fraction matches up with the formula. And theta is, oh, actually I miswrote it here. There's no theta there. This should be pi over 6. Then it matches up with my formula. So I'm going to get that negative still out in front, tan of 2 times my angle. And so using the formula, a little bit more work at the beginning, but as far as getting the value, a lot less work. Now I'm going to add a part C and a part D to this one, because both A and B used values that were already on your pi plate. Oops. So here's our C. Evaluate and I'm going to put pi over 12 in there. Now yesterday we did pi over 12 questions. So I could have given you this question yesterday. And if I gave you this question yesterday and it was a quiz question or a test question, it would be worth 7 marks. Because a pi over 12 question is usually 3 or 4 marks, and this would be 2 of them. So it would take a lot of space. You'd have to use your alpha and beta formulas, and it would be worth 7 marks. This question comes up on an exam, it's only worth 2 marks. And so you have to have your formulas mostly memorized because this matches up with the 2 sine theta cos theta part of one of your identities, the right-hand side. So the shorter way of doing this one would be to change this to sine of 2 times pi over 12. That simplifies to pi over 6. And what's sine of pi over 6? 1/2. A lot shorter than the pi over 12 part. But I will tell you that when you see a question like this, your brain will go to pi over 12 questions faster than it will think about using a double angle identity. So one of the things you have to train yourself is when you look at something, you're like, okay, I could do it that way. Are there any other ways I could do something as well? Before you just dive into one way of solving it. And then part D. You might get a value you've never seen before on a non-calculator part. Pi over 8. Then for sure you'd be looking at your formulas. Does this match up with one of our formulas? And it matches up with the cos one, cos 2 times pi over 8, which is just pi over 4. And you get the square root of 2 over 2. So questions 4, 5, and 6 for practice.